Welcome to the Explainer. So, you've already got a handle on using try and catch for those pesky exceptions in Java. Well, today, we're going to level up your skills by adding 3 more crucial keywords to your arsenal. This is going to give you total control over how your program handles errors.
Okay, so here's the game plan. First, we'll look at how you can manually trigger your own exceptions using throw. Then, we'll cover how you warn other parts of your code about potential problems using throws. After that, we're going to get into finally. This is the keyword that makes sure your cleanup code always runs. And then we'll wrap it all up with a look at your complete exception handling toolkit.
Exactly. This is such a key question. Up until now, we've mostly been on the defensive, just reacting to exceptions that the Java runtime throws at us. But what if your own logic, the rules of your program, run into a problem? Well, that's what we're talking about today. The power to create and launch your own exceptions.
All right, first up, let's see how throw lets you take charge of your program's error conditions.
So here's the big idea. Instead of just waiting for something to go wrong, like a file not being found, you get to be the one to sound the alarm. When your code hits a situation that you've decided is an error, you can use throw to literally stop everything and signal that something needs to be handled.
And the syntax is super simple. It's just a keyword throw, followed by, well, an object. But, and this is really important, it can't be just any old object. It has to be an instance of the throwable class or one of its kids, like null pointer exception or argumentation exception. You can't just throw a number or a string at it.
Okay, now check this out, because this example is really cool. Look inside the demo proc method. We're not waiting for an error, we're making one with throw new null pointer exception. Right away, the catch block inside that same method grabs it and prints a message. But then, look at that last line in the catch block. We use throw E to rethrow the very same exception.
And this flowchart shows you the whole journey of that exception. It gets created in demo proc, it's caught right away, but its trip isn't over. It gets thrown again, traveling up the chain of command until the catch block back in the main method finally catches it a second time. This is awesome because it shows you can handle an error locally and still pass it on for more general handling.
Now, that's all well and good if you handle the exception inside the method. But what happens if a method is designed to cause an exception but not deal with it? How does it tell the code that's calling it to be ready? This is where throws comes into play. You should think of it like a warning label on a method. When you add a throws clause, you're making a contract. You're saying, hey, if you call this method, you need to know that I might throw this kind of exception, and I'm not going to handle it. It's your problem now. And for many types of exceptions, this warning is mandatory.
And this comparison just makes it crystal clear. Look at the left side. That code will not compile, period. Why? Because throw1 throws a checked exception, but it doesn't declare it. The Java compiler literally stops you. Now, on the right, we fix it. Step 1, we add that throws illegal access warning label to the throw1 method. Step 2, in main, we call it from inside a try block, and we give it a catch block to handle the potential problem. Now, everybody's happy, and the program compiles.
All right, let's move on to finally. This is Java's rock-solid guarantee that your most important cleanup code will never, ever be skipped. And that's the promise of the finally block. It is the official cleanup crew of Java exception handling. It doesn't matter if your try block succeeds, or if it fails and gets caught, or even if it fails and doesn't get caught. The code inside finally is going to run. And this is absolutely critical for things like closing files or network connections so you don't leave a mess behind. And this table just drives the point home. It always runs. In proc A, an exception gets thrown, finally runs. In proc B, the method tries to bail out early with a return statement. But nope, finally executes right before the method actually returns. And in proc C, everything is perfect, no errors at all, and finally still runs. There are no exceptions to this rule.
So let's pull it all together. We now have 5 powerful keywords that make up our exception handling toolkit. Time for a quick review.
So here it is, the whole shebang. You try a block of code you think might be risky. You catch any errors that happen. You throw an error when you need to create one yourself. You use throws to warn other methods about what you might throw, and you use finally to clean everything up afterwards, no matter what. Getting these 5 down is really the key to writing solid, reliable Java code.
So the real takeaway here isn't just about fixing bugs as they pop up. This whole toolkit is about designing better, more resilient software from the get-go. By thinking about what could go wrong and managing those situations cleanly, you can build applications that don't just crash, they handle problems gracefully. So, what are you going to build with these new powers?